Now let's see what happens when we combine capacitors in electric circuits. When capacitors are in parallel, the left plates are connected together to the positive terminal of the battery, and their right plates are connected together to the negative terminal. The battery charges the capacitor until the voltage across them are equal to the battery's voltage, at which point the flow of charge stops. The key rule for capacitor in parallel is that the potential difference is the same across every capacitor and is equal to the voltage applied by the battery. Since the battery must charge all the capacitors, the total charge stored is the sum of the charges on each individual capacitor. So we have total charge equals charge on capacitor 1 and charge on capacitor 2. We also have for capacitor 1, the charge equals to capacitance for capacitor 1 times potential difference. Charge on capacitor 2 is capacitance 2 times potential applied. We can simplify the circuit by replacing the parallel capacitors with a single equivalent capacitor. We call it the CEQ as equivalent capacitance. The equivalent capacitor must have the same effect on the circuit as the original combination. For capacitors in parallel, the equivalent capacitance is simply the sum of the individual capacitance. So equivalent capacitance simply equals to C1 plus C2. Therefore, the equivalent capacitance is always greater than any of the individual capacitors in the parallel combination. In a series connection, the capacitors are connected end to end. When a battery is connected, it pulls electrons from the first plate and deposits them onto the last plate. Pull electrons from here and put electrons to here. This induces charges on the inner plates, with the result that all plates in the series have the exactly same amount of charge. So each plate will have exactly same amount of charge. For capacitors in series, the individual potential difference across each capacitor add up to the total voltage of the battery. We can find an equivalent capacitor that performs the same function as the two capacitors in series. So the two rules for capacitor in series are the charge is the same on every capacitor, and the total potential difference is the sum of the individual potential difference. So we can apply this. Total potential difference equals to total charge divided by equivalent capacitance equals potential difference of capacitor 1 plus potential difference of capacitor 2 and potential difference of capacitor 1 and potential difference of capacitor 2 add up to the total potential difference. And eliminate Q from this equation, we can find out the relation between equivalent capacitance to C1 and C2. this should be a plus. So because it's coming from this side. So 1 over equivalent capacitance equals to 1 over C1 plus 1 over C2.